So okay, considering two random variables, we have seen the expected value of a function of a random variable. So you could interpret this as, if you define g to be z, you could also interpret this as expected value of z. This of course you could do it this way. Simply find the density function of z and then you can find the expected value of z. But the disadvantage if you proceed this way is, of course, you need to find out the density function of z. Whereas if you are just interested in an average value of this random variable, as we saw, in general you could also use this expression. So and if that's all you are interested, so here the advantage is you can work with the what is known, which is generally the joint density function of x and y. As I said, as we discussed earlier, if these two random variables are independent, then this becomes a product. I mean, sometimes there will be advantage, especially if this function happens to be a product of two functions. So it's possible that this is of the form g1x, g2y. In that case, this would be double integral g1x, g2y, and in general this is xy dx dy. So here is, in this case, if x and y are independent, then of course the joint density function is the product of the density functions. And if you plug this in here, you see that the integrals are separate. So in other words, you can write this as g1x fxx dx multiplied by g2y fyy dy. But this is the expected value of g2y, and this is the expected value of g1x. So this is an interesting result by itself. If x and y are independent, the product of the expected value of the product, so long as each of the functions involve the random variables separately as g1x and g2y, is the product of the expected values. So of course this also says that if xy are independent, then expected value of xy is what? Anybody? Right, it's the product of the expected value. So this is what we used as a cue to define the correlation coefficient. Remember, so there the logic was the variance of any random variable is expected value of x minus mu x the whole square. Variance is a non-negative number. So similarly, variance of y is of course expected value of y minus mu y the whole squared. And so using these definitions, we define the covariance of x comma y to be expect. So idea of covariance is, if you put y equal to x, this definition should collapse to this. So here instead of square we have one of each. Right? So this definition is made up so that if you put y, x equal to y, this will go back to this, right? These numbers are in fact positive or definitely non-negative, whereas here since you are mixing this up, it could be positive or negative. Remember, we expanded this last time and showed you that this is actually expected value of xy minus mu x mu y, right? And I also showed you that covariance is less than, so if I call these numbers to be mu x sigma x squared and sigma y squared, then we had this relation also. In fact, what we had shown is the absolute value of the, so I'll write it in the next line. So we also showed that the absolute value of the covariance is, this is something we proved, less than or equal to sigma x or sigma y. But you notice here, you get a freebie here. Look at here. From here, what happens if x, y are independent? Anybody? If x, y are independent, what is the covariance of x, y? Because this becomes mu x, mu y, right? So that's why this is useful. So one corollary is if x and y are independent, the covariance is 0. Because of this property, we defined a dimensionless quantity as their ratio, covariance. So this way you can see why I didn't want to start with this definition, why everything is logical. Right? Of course, then this quantity, the way we have defined, rho will be always between -1 and +1. Rho is what we define as the correlation coefficient. So look at here, using what is the definition for covariance of x, y in terms of correlation coefficient? Anyone? How do you rewrite this? Covariance is what in terms of rho? What is it? What I don't want you to ask me is after 2 weeks, how do you get this? So covariance of two random variables, look at here, you can write in terms of the correlation multiplied by sigma x, sigma y by simply cross multiplying here, right? Why did I use this definition? I went through the logic because this is bounded by this. We want correlation means we want a number which is always between -1 and +1. So if two random variables are independent, the covariance is 0, the correlation coefficient is 0, right? And we also showed through many ways you can show. In general, the correlation equal to 0. If so, you have this independence. xy independent implies, of course, rho xy is 0. That is, xy are uncorrelated. But this way it's not true. X and y are uncorrelated doesn't mean they are independent. So the easiest way is, as we did, just to take a case. You could even take this case. So I construct two random variables. In fact, I construct them to start with x and y are independent, the way I have written, exponential. So let's say e raised to minus x plus y, x greater than 0, y greater than 0. Of course, x and y are independent. What I'm going to do is I'm going to create two random variables. So this works all the time. I'm going to show that these two random variables are uncorrelated but not independent. So uncorrelated is easy. What is the mean of W? Anyone? You can see these are identical random variables, so they have the same mean. So whatever is the mean of this is 0. Okay. And so let's look at expected value of ZW. So covariance of z comma w is what? Covariance of z comma w is here. Where is it? So you also have another expression. Covariance of x comma y is right here. Here e of x comma y minus mu x mu y. I'm just going to, so this is e of x comma y minus mu x mu y. So covariance of z comma w is expected value of zw minus this, but one of this is 0, so this term is not there. You're right. So this is simply this, but you don't have, so now you substitute for c and w. So this is expected value of x plus y multiplied by x minus y. That's x squared minus y squared. and this is expected value of x squared minus expected. Again, you can see because these two random variables are identical, they have the same variance, same mean. Even if I don't know the mean and variance, I know this quantity is 0. Right? So covariance is 0, correlation is 0. Now, I think we did this. You find out the joint density function of z and w. It will come out to be e raised to minus z. Remember, we went through all this. C greater than absolute value of w greater than 0. And this is c and w. From here, if you find out FCC, I think FCC will turn out to be two e raised to minus z 2z dc, and you find out of w. You will see that z and w are not independent. So they are not independent, but they are uncorrelated. So not independent, but uncorrelated. So what is the moral of this story? You start with the two identical random variables. It doesn't matter, it doesn't have to be exponential. It could be Maxwell or identical random variables, independent, so that their joint density function is the product. Then you know that each of them have the same mean, same variance, right? Yes? Whatever is the mean and variance, they are equal. Consequently, this mean is 0. These two quantities are equal, so they are always uncorrelated. Then you work out the density function and see whether they are. If it, in some rare cases, they may be also independent, but more, as a rule, this is not true. That's all I'm trying to say. And we also showed you last time there is an exception to this. The exception is the Gaussian case. Okay, so this should be clear. Now, a classic problem I ask at this point is, what is the variance of x plus y? So we could use this expression. So gxy is x plus y. That's what it is. Right? Remember, the definition of variance is what? Anyone? So you treat this as z if you want. So this is expected value of z squared minus mu c squared. What is mu c? Mu c is expected value of z. So this is expected value of x plus y. Expectation is a linear operation. So someone asked me that question by an email. So this is mu x plus mu y. So let's substitute it here. You also know that you can write this as like this, right? So whichever, this is also true, right? Either one will. So let's plug this into here. So this now reads expected value of x minus mu x plus y minus mu y, right? The whole thing squared, expected value, right? So this is like a plus b the whole squared. So what do you get? Anyone? If you expand that, what do you get? So first of all, there will be 3 terms inside, right? Inside this bracket, there will be 3 terms. So that will be x minus mu x the whole squared plus a middle term, which is 2 x minus mu x multiplied by y minus mu y plus y minus mu y squared. So what is the expected value of the first term? Anyone? Here. Expected value of the first term is not sigma x squared, right? Expected value of the last term is what? What is the expected value of this term, second term? Covariance of what? Y. Look at here. That's the definition. Expected value of this multiplied by this is what is covariance? What is the simplest form? Look at here. So I'm going to write it in terms of like this. So that's 2 rho xy sigma x sigma y. And the last term is? Oh, so this is the moral of the story. Look here. If you if you add two random variables, the variance of the sum is not the sum of the variance, is not, right? You have the sum of the variance is here, but you also have another term which depends on the correlation. So what happens if the two random variables are uncorrelated? What happens to the variance? If they are uncorrelated, middle term is 0, right? Because the correlation coefficient is. If the two random variables are independent, so when can you say the variance of the sum is the sum of the variances? Right, not all the other time. So what happens at that time if I put a minus sign here? Anyone? You go through all this. This minus sign is going to come here, isn't it? So let me write. Do you see now? This is true, right? If it is plus here, it will be plus. If it is minus here, it is minus. But if the two random variables are uncorrelated or independent, the variance is the same. Variance doesn't change. So if you subtract two random variables, you cannot decrease the variance. You add the random variables, you may say, I can see why the variance increases. But in terms of variance, so you add more uncertain, this is random. So whether you add or subtract another random variable, the variance only goes up. Right? Does it make sense? So if x, y are independent, you don't need independent, or uncorrelated, that's also fine. Right? You see this, right? Variance of the sum is of course the sum of the variances. Variance of the difference is not the difference of the variances. Also the sum of the variances, right? All right, so finally, just one more related issue with this. How about the variance of ax plus by? So again, define this to be z. So this is expected value of z minus mu z the whole squared. What is mu z? Anyone knows? What is the expected value of this random variable? Look at here. A mu x plus b mu y, right? So if I substitute that, this now reads expected value of ax plus by minus a mu x plus b mu y, right? So I'm going to arrange all the a terms nearby. So this now reads, what is it, x minus mu x, right? Plus b multiplied by y minus mu y. Look at there, right? So I'm going to square this. Again, I get three terms. So if I expand this, I have expected value of a squared multiplied by x minus mu x the whole squared plus 2ab x minus mu x multiplied by y minus mu y plus b squared multiplied by y minus mu y the whole squared. So if you put the expectation through, what do you get? What is the first term you get? A squared is a constant. So a squared sigma x squared plus all right, so this should be clear to you. Once again, so what happens, what is, so how will you find the variance of 2x? Anyone? So look here, so b is 0, so b is 0, this term is gone, this term is gone. And so if this is simply a, the answer is a squared sigma x squared. So if you multiply a random variable by a constant, the variance is not multiplication, it gets squared. But this should be more. So what is the variance of x plus 2y? You don't have to do much, you don't have to, people immediately get confused. So you x plus 2y will be what? So it will be sigma x squared plus b is 2, right? So substitute it, a is 1, b is 2. Yeah, whatever. And so this is always a little, so let me give you an interesting problem before I summarize on this one related to this variance. Say you have, this comes up in stock market, you have some capital, you want to invest into two stocks, X and Y. So question is, this is the way you build up a portfolio. You put some, you don't want to put all your money into one commodity or stock. So you want to put it into several of them, but let's take two of them. So I want to put a fraction of my money into this one, and remaining, of course, capital goes into this here, right? So my portfolio is aX plus 1 minus AY. So think of this as the return from Apple and return from Google. Anyway, two different stocks. So what is the problem here? Of course, you know how much money you have. So let's say you have $100,000. Not you, somebody else, right? So what is the unknown here? Hello, what is that you want to find out? Anyone? You know, of course, how much money you have. What is that you don't know here? You also know where you want to invest. How much what? How much you make? That depends on how you do in the, huh? How much you invest into each, this fraction, this is the unknown quantity. So look at your return. Return is expected value of the average return. See, look at here. It depends on the returns of this, right? So what is the A multiplied by expected value of X plus 1 minus A multiplied by expected value of Y. So you may say the Apple historically has been giving 10%, and this has been, whatever is the second one, has been giving 8%. So if you know A, then I know what I can expect from this return. Okay. So this is, let's say, 10%, and this is A. So those numbers are known. So I'm going to write, as you said, I'm going to write this as A mu X plus 1 minus A mu Y. What is the, what did you say? What was the problem? Why bit of, because that's what I'm trying to say. You need to listen when I'm, you have some money, right? Let's say you have $1,000. You want to invest, that's all you have to, you are going to invest this money into these two. So you have to distribute this money, fraction of it goes here, fraction of it goes here. So my assumption is this is the money I'm willing to invest. So all that money has to go into 2 or 3 or 4 stocks, whatever. So I'm just taking the simplest problem. 2. Another reason to invest is because if you look at each stock, this is the volatility. And the other one may be also like this. So this is, so generally you have to measure the volatility. From what we have learned, what is a good measure of the variation? Anyone? For each stock, how do you quantify the volatility? Or volatility is what you see there. One? No, we have, remember, we have few parameters, mean, variance, correlation, etc. It will be variance, right? Mean is for the return. So you could take the standard deviation, which is the square root of the variance, as a measure of the volatility. So if you have to have a strategy, what is that you are looking for you want to make a combination such that the volatility of the portfolio is what? Less. Of course we are close. So you don't want very violent variations, because if it is millions of dollars invested, 10 million becomes 1 million and you get a heart attack, right? So you want the portfolio to do something like this, preferably. So let's compute the variance of the portfolio. So that's expected value of P minus mu P, right? The whole squared. So let me substitute for P. It's exactly the same problem, right? So this is going to be expected value of A multiplied by X minus mu X plus B 1 minus A multiplied by Y minus mu Y, right? Once you substitute squared. So if you expand, what will you get for the variance of P? Anyone? You can just borrow from there. What is it? It will be exactly this, right? Yes. So this is A squared sigma X squared plus 2A rho sigma X sigma Y plus 1 minus A squared sigma Y squared. Now what? We want to minimize this subject to what? With respect to what? What is the variable in our hand there? So how will you do minimization? I want to minimize this with respect to A. How will you do that? Right, so take the derivative with respect to A. So what do you get? Yes, what do you get? So this is A minus A squared, right? 1 minus, is it? 2 here, if this I can write it as A minus A squared. So derivative of each term, right? Derivative of this is 1, derivative of this is 2A. Minus, what is the derivative there? 2? Yeah, this is correct, right? Sigma Y squared equal to 0. So, see, that's only, so what is the value of A? Let's do it correctly. Oh, something I missed here, right? So if I collect all the terms, this is sigma X squared. Equal to what? Sigma Y squared, right? Is it? So you can solve for A. A is going to be, if I did everything right, is this right? Yes? So you see the numerator, of course I can write this as sigma Y is common, then sigma Y minus rho sigma X, right? Because previously I had this, so I can pull this out. Now, you want A to be what? What is the condition on A? Anyone? What? What did you say? Minimize. No, it's already minimized, right? No, I mean, the condition on A is here. A need to be, remember, it's a fraction of this money, so A need to turn out to be positive, right? So you need to, if you try out certain, if you have to check the values of this for certain stocks, this will turn out to be, this you can show it to be always less than 1, but what may not be true is when whether this will turn out to be positive. What is one case? We know sigma X and sigma Y are positive, right? Rho could be positive or negative. What is one case where you know guaranteed the solution will be fine? Rho is negative. If rho is negative, which is A will turn out to be positive. A is a fraction. You can quickly check out that this quantity is less than this. The denominator is always positive. Hello? Denominator is positive. Why? Because this is the same as the variance, right? So that's, look at that. This is the same as that term with the A equal to 1. So the denominator is positive. But it is possible that this variance, sigma y, is less than these quantities if rho is positive. But if rho is negative, this whole thing will be positive. So you might have heard this. If you are investing into two stocks, it is best to invest the stocks which are negatively correlated, so that when one goes up, the other one goes down. But in that case, you can also build a portfolio. Now you can take this value and plug it in here. That will give you the minimum value of sigma p squared. So if you plot you should be able to see things like this as a value of A. So there will be some minimum value. So it all depends. So the whole point is it all depends on also the value of the correlation. So just by looking at two stocks, you wouldn't know how much money to put in. It also depends on rho xy. Okay? And you can of course expand this into multiple stocks. This whole topic comes under portfolio optimization and so on.